Okay, hypothesis testing. Hypothesis testing is when we have a sample and we believe that it proves that some claim is wrong. So let's say that we had the percentage of people who lived in East Plano, of all the people who lived in Plano from 2000, and we wanted to show that the same percentage lives there now, or that it's not, that it's more, that it's less. Then we could use hypothesis testing. Say I took a sample and it turned out my sample had a much higher percentage. Then I could say, well, I think I proved it, but let me make sure that my sample size was large enough and the difference was large enough and so forth. The null hypothesis for a two-sample test is always that the means are the same or the proportion is the same. The null hypothesis for a chi-square goodness of fit test is always that it does fit. The null hypothesis for a chi-square test of independence is that they are independent. The null hypothesis is always the I have not proven anything hypothesis. The alternative hypothesis is the thing that I'm trying to prove. So we can either say, I don't know if it's bigger or smaller, but I think it is different. That's a two-tailed test. Or we can say, I really think it's less. Then that means that my sample must have been less, and so it's a left-hand test. Or it could be that I think it's really bigger. That means my sample landed over here bigger, and so it's a right-tailed test. So if you want to show, for example, the mean temperature in a coastal town is less than 78 degrees, that means that my average was less than the expected average, so I'm a left tail. The mean grade point average of graduating seniors was at least 2.3. That means bigger than or equal to 2.3. So I do bigger than, and then I come over and do a right-hand test because my value was bigger than 2.3. This one is worded a little strangely, but it says the mean income for LA Mission faculty is $4,500, is equal to. So we would be testing if it was not equal to. So that's what we would try as a not equal to. That's a two-tailed test. And then the proportion of full-time college students younger than 26 years of age is at most 90%. At most 90% means less than or equal to 90%. So we do less than 0.9. My value must have been less than it. The proportion of high school graduates in 1990 seeking full-time employment was more than 30%, so my sample must have been higher than the mean, so I'd have a right-tailed test. Okay, so a type 1 error, again, is if I reject the null hypothesis, but I should not have. That's a type 1 error. A type 2 error is that I did not reject it, but it's false. I should have rejected it, but I didn't prove that it was false. When you go into a test, you have alpha. Alpha is usually set by whoever tells you to do the test. Maybe you're doing it on your own and you choose alpha, and maybe you even choose alpha to get the result that you want. Alpha is the amount of probability you're willing to accept that you will commit a type 1 error. So going into the test, knowing nothing else, if you start out with alpha equal 0.05, you're allowing a 5% chance that you will commit a type 1 error. Type 2 error is sort of more difficult to calculate. This makes you feel like it's inversely proportional. It's not. But because alpha, if I increase alpha, so I increase the chance of a type 1 error, I increase the chance that I reject the null when I shouldn't have, that means I'm making my rejection regions bigger. That makes it less likely that I will fail to reject something that actually is false, because my rejection regions are now large. So as the probability of a type 1 error increases, the probability of a type 2 error decreases. Okay, so I'm going to skip over this for the moment. So let's look at this very quickly. If I reject the null when the alternative is true, so if the alternative is true, then the null is false. And I rejected it. So I did a great job and I'm happy. If I rejected the null when the null was actually true, that's a type 1 error. If I didn't reject the null and the null was true, I didn't say no to the null and I shouldn't have, and so I was right, so yay. If I do not reject the null, but the alternative is true, so if the alternative is true, that means the null is not. The null is not true, but I did not reject it, so that's a type 2 error. And this is one way to think about it, because in our courts, you're innocent until proven guilty, and in the hypothesis test, the null hypothesis is assumed true until you prove it's not. So a guilty person who is convicted is right. An innocent person who's acquitted is right. If an innocent person is convicted, then that's a type 1 error because the null was true, but you rejected it. They told the truth and you rejected it. If a guilty person is acquitted, that means they lied, the null was false, but you bought it. You didn't reject the null. So that's a type 2 error. We've spent a lot of time on hypothesis testing, and it's time to go to clubs, as you can probably see from right there. So I'm going to, the type 1 error was probably something we didn't talk that much about, and the difference between alpha and p-value we didn't talk much about. So, I think that I'm going to go ahead and upload these as they are. And if you guys have questions, please let me know immediately.